Okay, so for Unit 12, it's just like Unit 11, except we're going to use different calculator functions, and we're going to talk about it a little bit differently because Unit 11 was about proportions and Unit 12 is about means, but a lot of the same things. So again, you're going to have to write interpretive sentences in order to make connections between related variables, but there's a lot that your calculator will do. So it has the same sequence as Unit 11, a different formula for minimum sample size, but same sequence again. So let's get started. This first video is about example 1. And so your formula for determining the minimum sample size, again, N is your minimum sample size, but now your formula is a lot less complicated, I think. You're always going to be given your standard deviation, and then you just have to figure out your Z alpha over 2 and your error. Okay, so just like Unit 11, we're starting with identifying what is being studied. But remember, proportion used to always be between 0 and 1. A mean can be any number. It does not have to be between 0 and 1. So the mean being studied in this problem is remember this is now the symbol for the mean of a whole population. And so the mean being studied in this problem, where it says a college president claims the average age of students at his university is 20.7 years old. So we'll say the average age of university students. And then it says to write the null and alternate hypothesis statements and identify which is the claim. So the college president claims, oh, look, it's right there, claims that the average is 20.7 years old. So he is claiming, remember this mu is like a U with a long front, that mu equals 20.7 years. And so because that has an equals, that is our null hypothesis, just like when we did proportions, the alternate hypothesis is going to be the opposite. So we're going to say that the mean is not 20.7 is the other one, but this guy is the claim. Okay, so quick reminder, when you have a null, now it's going to be the mean equals, or the mean is greater than or equal to, or the mean is less than or equal to. And the alternate that goes with it is that the mean is not equals, or the mean is less than, or the mean is greater than. Just like with proportions, these guys go together, these guys go together, these guys go together, and the null has an equals, and the alternate does not have any part of it being equals. So not greater than or equal to, not less than or equal to, and then not equal, just like with Unit 11. Okay. So that's our claim, and that's our null and alternate. And then it says the teacher would like to be 99% confident that their study should be accurate within 1 year. So that means plus or minus 1 year. That's our error. From a previous study, the standard of deviation is known to be 3 years. Okay, so how many students should be surveyed? So this is really similar to what we have done before, just a new formula. So let's go back up here and find our formula. All right, so I'm going to copy down that formula. N equals Z of alpha over 2 times standard deviation over error as a decimal squared. So I know the standard deviation, I know the error. Oh, sorry, I said it as a decimal. It's not a decimal, it's just 1 year. But I need to find the Z of alpha over 2. So I know since the confidence level is 99%, that means that my alpha will be 1%. And if you think of it as a normal curve like we have been, the 1% is being split into 2 places. And that's regardless of what kind of hypothesis test this is. It's just because it's Z of alpha over 2. And so alpha over 2 is like half of a percent. So be careful with how many zeros you do there. And so the z of alpha over 2, we're going to once again use inverse norm. And again, you can do inverse norm left or right. Inverse norm of 0.005 and then 0 and then 1. Left, if you did right, it would get you this score, which is the positive one. This one's negative. And once again, it doesn't matter because we're going to be squaring it. So that I already calculated that, and it was negative 2.58. Remember, inverse norm is in your distribution menu. Second bar is 3. So I will put negative 2.58. And then we said that our standard deviation was 3. And then we said that our error was 1. And so then I'll just do all that and square it. Okay, so let's pull up our calculator. And I will put this in negative 0.58 times 3. Dividing by 1 doesn't do anything, but just I'm going to put it in. All right, and then squared. And I squared it on purpose after I hit enter so that I don't make a mistake with negatives. So I get 59.9076. 59.9076. And remember that when you have a decimal, no matter what it is, you're always going to round up, even if it was 59.01, because this is a minimum. So if I go below it, that's not okay. So n equals 60, and 60 would be, is it 60 years? Is it 60 students? How many students should be surveyed? So it would be 60 students. So basically, he should survey 60 students to be 99% confident within an error of 1 year. And then we use a standard deviation from before. So check out the next video for example 2 and then for example 3, or you could try them yourself and then check the video or check the key.